Hello friends, thank you once again for joining me. Today we have a case of inequality where we are asked to solve an inequality. What we have here is an example of what we refer to as a compound inequality. But before you continue, I would request you to subscribe if you haven't. And at the end of this presentation, if this interests you, I'd also request you to share it with your friends, make a comment, and also press that bell buttons so that in case I post a new video, you'll be alerted. Now what we have here is a case of a compound inequality. Now the middle term here is common to both the left and the right hand side, and it's advisable that you deal with one each side at a time and then later combine your answer and come up with a compound solution to the compound inequality. So I would like to begin with this. Now here we have 5, 1 is less than or equal to, or 5 minus 2x over 3. Now what I would start with here and what is advisable is to multiply both sides by the LCM, in this case LCM of 1 and 3. Whenever we have a whole number, the denominator is 1. So here we have a fractional algebraic fraction whose denominator is 3. And here we have a whole number, negative 1, which can also be written as negative 1 over 1. Then we multiply through by negative 3 just to make our work easier so that we deal with the whole numbers. Remember, by multiplying both sides by negative 3, we are not changing the meaning, we are actually changing the appearance and for our convenience. So if you multiply both sides by 3, this translates to now negative 3 is less than or equal to of 5 minus 2x. Then I would collect like terms. We'll solve algebraic inequalities in much the similar way to how we solve linear equations, algebraic equations. So in this case, collect like terms. So I'll take my 5 to this other side, and then when I bring it to this other side, it will be negative 5. So we'll have minus 3 minus 5, which is negative 8, less than or equal to negative 2x. So we solve for x, we divide both sides by negative 2, we divide both sides by negative 2. So remember, we are dividing both sides by negative 2, and whenever we do that, the inequality sign must change. So that here, this will be 4. Any inequality, you should be aware of this. When it's multiplied or divided by a negative number, the inequality sign changes. So we've solved the left-hand part. Now we come to the right-hand part. So we have the same 5 minus 2x over 3 is less than 2x minus 1. Again, as we did earlier on, now what we have here, we can put it over 1, then multiply both sides by 3, just to do away with the fraction, and we take the LCM of 3 and 1. So in this case, this cancels this, so we'll have 5 minus 2x is less than, now our 6x is 3 times 2x minus 3 times negative 1, which translates to negative 3. Then, as we did earlier, we collect like terms. We'll take 2x to this other side and bring 3 to this other side. So when I bring 3 to this other side, it's negative. It comes this other side, it will be positive. So we'll have 3 plus 5, which gives 8. Then it's less than, now 6x plus 2x gives us 8x. When this negative 2x crosses this the inequality sign to the other side, it becomes positive. So we have 2x plus 6x, which translates to 8x. Now we divide both sides by 8 because we want the value of x. So we have 8. So in this case, x is greater than 1, or we can say 1 is less than x. So these are the two solutions that are attached to that one inequality that we have. Now, because it was a compound inequality, our solution must also be a compound solution. So we combine these two. So because we have x is less than or equal to 4, but x is greater than 1, it's always advisable to start with a smaller number on your left-hand side. So like in this case, we know from here 1 is less than x, or x is greater than 1, so we have this. But the same x is less than 4, so this, and this is the solution to that inequality that we are given. Thank you so much for your audience. Once again, I request you to subscribe and share with your friends. Bye for now, and always take care.